Good afternoon. We are going to do the notes for Chapter 6, Section 3, Properties of Parallelograms. And a lot of this chapter is going to be if you have a parallelogram, then certain things are true. There's a summary here at the top, but we're going to go through them one by one. All right, Roman numeral 1, parallelograms. Let's start with the definition. The definition of a parallelogram is it has to be a quadrilateral, which is a four-sided figure, and then both pairs of opposite sides are parallel. So if we call this A, B, C, D, if it's a parallelogram, then we know automatically AD and BC are parallel, AB and DC are parallel by the definition. Okay, so example 1. One of the ways you're going to see parallelograms in the text is with a small drawing of a parallelogram followed by the vertices. You will see me use another shorthand, which is less official but a little more convenient. Parallelogram A, B, C, D. So those are both ways that you're going to see parallelograms listed on our problems. All right, so let's look at example 2. Which of the following are parallelograms? Okay. So ABC, or sorry, part A here, this is not a parallelogram because the sides are not parallel. B, you have one pair of parallel sides, but you're missing another pair of parallel sides. So this is not a parallelogram. This actually would be a trapezoid. C, yes, it's a rectangle, but if you'll notice, the left and right sides of the rectangle are parallel. The top and the bottom sides of the rectangle are parallel. So yes, C is definitely a parallelogram. D, this looks like a square. It is a square. But you'll notice top and bottom sides are parallel. Left and right sides are parallel. So a square is another parallelogram. On the last one, this is a four-sided figure, but only one pair of sides are parallel. So this is a trapezoid, but it's not a parallelogram. Okay, part B, diagonals of a parallelogram. This is a review. So the definition of the diagonals is a segment joining two non-consecutive vertices of a polygon. So we're going to draw diagonals, if possible, on figures A through E. All right, well, this triangle has no diagonals because if I use this left-hand vertex, there isn't another vertex that's not consecutive, so there are none. For B, you can connect opposite diagonals. This really looks like an isosceles trapezoid, doesn't it? Because the diagonals are congruent. Yep. And we're going to draw in the diagonals for the rectangle. Those actually look congruent too, don't they? And let's draw the diagonals on the square. Those diagonals look congruent. And on the last one, this is a trapezoid, but it's not isosceles. And yeah, you can tell they're going to be different. So diagonals of a parallelogram go from corner to corner. All right, flip the page. Let's get into some of our theorems. And we have a whole set of them, but they're really pretty easy to understand. Pretty convenient. All right, Theorem 6 7. If a quadrilateral, that would be a four-sided figure, if a quadrilateral is a parallelogram, then opposite sides are congruent. So here's our if figure. Our if figure is a parallelogram, so AD and BC are parallel. AB and DC are parallel. That's the definition of a parallelogram. So given this, then this theorem says AB and DC are congruent, AD and BC are congruent, but not necessarily congruent all four around. All right, theorem B6-8. It starts out, if a quadrilateral is a parallelogram, then, here we go, consecutive angles are supplementary. Consecutive angles are supplementary. Okay, so here's our if. We start with a parallelogram. So AD and BC are parallel. AB and DC are parallel. And let's say that angle A is 150 degrees. Using this theorem, if we already know it's a parallelogram, we know that A plus B has to be 180 degrees. So angle A plus angle B has to be 180 degrees, which means B must be 30 degrees because they are supplementary. A and D are also adjacent to each other. So angle A plus angle D also equals 180 degrees, which tells us D is 30 degrees as well. Using the same theorem, if D is 30 degrees, then it is supplementary to C and A. So angle D plus angle C has to also be 180 degrees. So if D is 30, C must be 150 degrees. So you can see that all of the consecutive angles are going to be supplementary, all four. Okay, Theorem 6-9 starts out very similar. If a quadrilateral is a parallelogram, then opposite angles are congruent, which we pretty much discovered on the last theorem because your 150s have to be across from each other, as do the 30s. All right, so the if is if we have a parallelogram. So if the left and the right are parallel and the top and the bottom are parallel, then we can say that angle A is congruent to angle C and angle D is congruent to angle B. The angles across from each other are congruent. All right, Theorem 6-10. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Notice it doesn't say the diagonals are congruent. It just says they bisect. So the if, we start with a parallelogram. So AD parallel to BC, AB parallel to DC. If that's the case, then when I draw in my diagonals, let's see, I'll draw one from A to C. And I draw the other diagonal, which is D to B. Even though those two diagonals are different sizes, they do still bisect. So AC is broken into congruent pieces, and DB is broken into two different congruent pieces. The diagonals bisect. All right, flip the page. We're going to do some practice. All right, example 1. RSTU is a parallelogram, okay? Find the values of X, Y, A, and B. And we're also going to give the reasons because that's what you'll be doing on your homework. Okay, so let's start with X. Well, if U is 80, opposite angles are congruent, so X must be 80. So X equals 80 degrees, and our reason is opposite angles are congruent. I'm also having you write the reason so I can show you some acceptable shorthand. Okay, Y. Well, we know that any angle is supplementary to any adjacent angle. So if U is 180, Y has to be 100 because they are supplementary. So our little mini equation, Y plus 80 would have to be 180. And when you subtract 80 from both sides, y equals 100 degrees. And again, your reason would be consecutive angles are supplementary. They add up to 180. Okay, now we're looking at A. Here's A. The side opposite A is 6, so A must also be 6. So A equals 6, and the reason is opposite sides are congruent. Now B is across from 9, so B equals 9 for the same reason. Opposite sides are congruent. So a lot of these you're going to have to say why as well as giving an answer. Okay, let's do number 2. RSTU is a parallelogram. Find the values of x, y, a, and b. Okay, so let's start with x. X looks like the entire angle there. So we know that angle R and U are adjacent to each other, which means they're supplementary. So I can take x degrees plus these two together, so 45 plus 35, and that has to be 180 degrees. And again, the reason, consecutive angles are supplementary. And we solve, and I'm not going to go through all the solving steps because it's pretty easy. X ends up being 100 degrees. So this angle right here is 100 degrees. All right, let's look at y. Okay, here's y. Now, this is a kind of an old one that we've done before. Because this is a parallelogram, RU and ST are parallel to each other by the definition, which means that U to S could be a transversal. If that's a transversal, then alternate interior angles are congruent. So 45 and Y must be congruent. So that would be our answer. Y equals 45 degrees. And the reason would be alternate interior angles are congruent. So every diagonal that you have in a parallelogram actually will give you two pairs of congruent angles, the alternate ones. So you have quite a few things you can get out of that. Okay, A. Here is A. It's the right side. 12 is the left side. So A equals 12 because opposite sides are congruent. All right, now the last one. B is from T to where the diagonals intersect. We know that the diagonals bisect each other, which means B and 9 have to be the same. So B equals 9, and the reason would be the diagonals bisect. Okay, let's move on. Number 3, find the values of x and y. Okay, let's start with x. We know that if it's a parallelogram, and we're assuming this is a parallelogram, we know that opposite sides are congruent. That's our theorem. So 4x and 8 are congruent. So 8 equals 4x would be our first equation. 8 divided by 4 is 2, so x equals 2. Using the same theorem, opposite sides are congruent. Oops, I forgot to put an extra mark here, didn't I? Should be 2 and 2. We know that 3y plus 4 and 13 are going to be congruent. So we can take 3y plus 4 and set it equal to 13, which will give us something to solve. So subtracting 4 over to the right, we get 3y equals 9, which means y is 3. And that would be what your work needs to look like. Box the equation, solve and get the answer. Okay, number 4, again, we're given in the directions that this is a parallelogram, and we are using the theorem that says in a parallelogram, the diagonals bisect each other. The diagonals are not equal to each other, but they do bisect. So looking for x, that means that 18 and 2x plus 8 have to be the same. So 18 equals 2x plus 8 is your first equation. We're going to solve for x, so we subtract 8 over to the left, so 10 equals 2x, which means x is 5. All right, now we're going to do the y. Again, diagonals bisect, so 4y minus 2 and 22 have to be the same length. So we're going to set 4y minus 2 equal to 22, box that equation, and solve for y. So add 2 over to the right. 4y equals 24, and 6 times 4 is 24, so y equals 6. Again, this is how your work should look. Equation, solve, answer. Equation, solve, answer. All right, flip the page. Okay, find the values of x and y. Okay, so these x's and y's are in kind of split angles. We can use, there's actually a couple different things that we can use. One of them, though, kind of leads to a dead end if you jump the gun. We do know that consecutive angles are supplementary. That is true. So these two plus the 80 should be 180. So 4y plus 5 plus 11x plus 80 has to be 180. That's a good equation. The problem is, though, that we have an x and a y in the same equation. So we need to see if we can solve for x or y and then substitute that value into our equation. Okay, so here I have an expression for y. If we treat RU and ST like parallel lines, because they are parallel, that would make R to T the transversal. And we know that alternate interior angles are congruent. Alternate interior angles are congruent. So 4y plus 5 has to be equal to 45. That is something we can solve. So let's solve for y. We're going to subtract 5 over to the right. So 4y equals 40, which means y equals 10. Now that we have our y value, we can take that value and substitute it into our other equation and solve for x. So I'm going to replace y with 10, so 4 times 10, and the rest of the equation stays the same. And to solve for x, we probably need to simplify the left. So 40 plus 5 is 45, plus 80 is 125, plus 11x equals 180. Subtract the 125 over to the right. You get 11x equals 55. 55 is 5 times 11, so x equals 5. Sometimes the equation you get is good. It's just it has more than one variable, so you need to solve for one of them first and then use your equation. All right, last one today is going to be in a coordinate plane. There are going to be questions that you'll need to use graph paper for. Anything with points, you need to use graph paper to do your work. It says 3 coordinates of parallelogram x, w, y, z are given. There you go, just not the z. Plot the points and find the coordinates of the 4th vertex. Okay, so let's plot the ones that we've been given. X is 4, 3, so 1, 2, 3, 4 to the right, 1, 2, 3 up. That's our x. W is 1, negative 1. Y is negative 5, negative 1. 1, 2, 3, 4, 5, and down 1. All right, so using my ruler, because it's a graph, and we always use our rulers on graph, I've got 2 sides of a parallelogram. Okay, so what they're wanting to do here is see if you understand that opposite sides are parallel if it's a parallelogram, which means opposite sides have the same slope. So in a coordinate plane, you need to find that fourth point. You need to figure out the slope of the side opposite. Now remember, slope is equal to change in y over change in x. So if I use w and x to find the slope, so the slope of wx equals, okay, so in the y direction, 1, 2, 3, 4, we go up plus 4. 1, 2, 3, 4, 1, 2, 3. Yep, that's right. Okay, so we go up 4. So the change in y is 4. And then the change in x, 1, 2, 3. Plus 3. So our slope is 4/3. 4 in the y direction, 3 in the x direction. So using that, I'm going to go to y and I'm going to count slope. I'm going to go up 4 and to the right 3. 1, 2, 3, 4. 1, 2, 3. And see if this is where my z should be. So if I draw in, let me switch colors here. If I draw in the remaining two sides, we can see if this looks like a parallelogram. Yep, it sure does. So that means that point Z is, let's see, -2 to the left, and then up 1, 2, 3. So -2, 3. Now, some other things you're going to be doing with figures in coordinate axes is they're going to ask you for the length of a side. Remember that you have a distance formula. Distance is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And in order to find distance, you need point 1, which is x1, y1. And you need point 2, which is x sub 2, y sub 2. So basically any 2 points you can use to find the distance. If you need to find the slope, you can count slope if you're graphed. If not, remember your slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The last formula you're probably going to need is midpoint formula, because the diagonals bisect each other, so you might be looking for the midpoint of a diagonal. Remember that it's the average of the x's, so x sub 1 plus x sub 2 divided by 2, and the average of the y's, y sub 1 plus y sub 2 divided by 2, and that will give you the midpoint, which you might need when looking for the midpoint of a diagonal. All right, I hope those formulas are helpful. Have a wonderful afternoon.